Good morning, and it is Thursday, March the 26th, and welcome back to answers from the previous day's questions. I hope everybody's doing well and staying up with these math problems. I really do enjoy these. It makes my mind kind of engage in the math and the science ideas. So yeah, keep up with this. It's a lot of fun, and it's a way for us all to kind of keep a regular schedule. So I'm going to go over the answers to March 25th assignment. This first one could be really tricky, or it could just be kind of an easy brute force problem. I'm going to show you kind of the brute force method because to get into the algebraic way of solving this, it's a little bit beyond what we're ready for yet. So let me just go ahead and do it the way that I think would be easiest for you to solve. So it says that Jay's dog outgrew his rectangular pen that measured 10 feet by 14 feet to make it larger. He increased each side length by the same amount, which increased the pen's area by 81 square feet. What is the greater side length of the larger pen? Okay, so as a lot of us fifth graders in the class, sorry, fourth graders, this is going to kind of be new to you, probably. I don't think we've discussed it that much. Whenever things grow, either by area or by volume, they grow a lot quicker than you think that they would. So let's take a look at this. I'm going to make a ratio table, and what we're going to do is we're going to have, um, we'll say length, width, and then the resulting area. And if we start off with the length being 14 and the width being 10, which is what we have, we get an area of 140. And the unit in this is going to be feet squared. Okay, so now the thing is that each one of the sides have to increase by the same amount. So let's do that. So let's increase each one by 1 and see what happens. If this is now 15, this would then be 11, which gives us an area of 165. And I'm going to assume that you guys know that I'm referring to feet squared. Okay, so let's increase by another one. We're still not there yet because what we need to do is increase by 81 square feet. So let's figure out what the target is, right? So if we start with 140 and we need to add 81 square feet, okay, that is going to be 221. That is our target. Okay, we're waiting to get to 221 in the area column. Okay, so let's keep going. If we increased it to 16 and 12, we would get a resulting area of 192 square feet. Okay, so we're still not there, but we're getting close because remember, we're trying to get to 221 by increasing 81 square feet to the existing 140 square feet. Okay, so let's try one more. 17 and 13. And guess what? When you multiply those two by each other, you get 221 feet squared. And that's exactly what we wanted. Okay, so it says, what is the greater side length of the larger pen? That would be 17 feet. All right, let's move on here. Let me quickly erase my scribbles. It's like the whiteboard, except I don't have those black smudges everywhere. Okay. All right. Here we go. Okay, number 2. Oh, what happened here? Okay, I guess we'll just leave that for now. Okay, so Parker has 3 sons, and I like that because my son's name is Parker. Okay, so we have Alfred, Beto, and Dell, with Alfred being 11. So we'll just leave this up here as like a little note-keeping area. Alfred equals 11. Beto equals 9. Okay, and Dell was 4. D equals 4. So what we're going to think about is that Beto is 2 years younger than Alfred, and Dell is 7 years younger. So whenever we find their ages later in life, we're going to subtract 2 for Beto, we're going to subtract 7 for Del. So what we're going to do is we're going to find Alfred being 37. Okay, what we need to do is we need to find the average of their ages when Alfred was 37. Now we find averages by adding all of the numbers that we have together and dividing by how many data points there are. So let's do this. Beto, we know, is 2 years younger than Alfred, which would make him 35. Okay? All right, well, Del was quite a bit younger, and he's 7 years younger than Alfred. Oh, let's not make that a 3.7. Oh, okay. So that would make Del 30 years old. When you add these three numbers together, okay, it gives us 102. All right, so what you do now is you need to divide by how many data points there are. In this case, there's 1, 2, 3 data points. So we are going to take 102 divided by 3. Okay? Well, we could do this algorithmically, but let's take a look at this. We know that 3 times 10 is 30, and 3 times 20 is 60, and 3 times 30 would be 90, okay? So how many more 3's would we need to get from 90 to 102, okay? So that's going to be 4 more 3's. So if you add it to the existing 30 that we counted, you would get that the answer is 34. Okay? All right. You could also, of course, do this algorithmically, but it's nice to find these nice mental shortcut, and that would be years. Let me clean this up a little bit. I'm not sure where all that residual marks came from, so we'll clean this up as best we can before we work on our last one, and hopefully it doesn't do the same thing that would just happen. Once again, I'm still learning how to be good at using Screencastify and work with a stylus. Luckily, my laptop turns into a tablet, which is very helpful for stuff like this. All right, so let's go. Once again, it's doing it. Okay, we got a little clear spot down here to work on. That's okay. All right, Kendra surveyed 100 people who own a dog or a cat or both. Of those surveyed, 15 own both a dog and a cat. And the number of people who own a dog is 4 times the number of people who own a cat. How many people surveyed surveyed own a cat? So let's take a look at this. I always like to think of problems like this. Sorry, let me bring it back up for us. Problems like this remind me of a Venn diagram. We have either cats or dogs or both. So let's make this one dogs, okay, and this one cats. And in the middle is going to be both. All right, it says that 15 people, which is the number in the middle, own both, okay? So we have 85 people left between owning either a dog or a cat. And we know that the dog owners is 4 times more than the cats. So there's a couple ways of thinking about this. I can make cats a variable and call it C, okay? And I know that C times 4 is going to be my dogs, okay? Now let's do this. So if we have 15 people who own both, right? Plus 4 C's. Remember, if there's no sign between the number and the letter, that means multiplication. There's 4 C's for dogs. That's dogs. Plus, how many people own cats? We should get 100. Okay. Now, this leaves us with 15, and I'm going to add up all my C's. I have 4 C's here, and then I have 1 C here, which gives me 5 C's equaling 100. Okay. Now, algebraically, I'm going to balance my equation. I'm going to get rid of the 15 over here. I'm also going to subtract 15 from this side to make my equation balance, which leaves me with 5C equals 85. Okay? Now, I got to figure out 5 times what number is 85? And we know from other work that we've done that we do that by taking 85 and dividing it by 5. So 85 divided by 5 is 17. Now, what does that give us? That gives us the value of C. And luckily, that's exactly what they asked for. They asked for how many people surveyed own a cat, which is 17. You know, there's another way that I was thinking about doing this too, which would be effective. You know, if it's 4 times more people own dogs than cats, then we could do something else where we know that if 15 of the owners, sorry about the mess, if 15 of the people have both, right, then 85 people left over have either a cat or a dog. And if I have 4 times more people owning dogs than cats, then I need to divide this into 17 equal parts. One part would then be cats. Sorry, not 17 equal parts. We would divide this into 5 equal parts, right? Because 1 part would be cats and 4 parts would be dogs. So we would divide this by 5 and we get the same thing, right? So it'd be 17. It's kind of like saying 1/5 of 85 is going to be cats plus 4/5 are going to be the people who own the dogs, right? All right, so 17 is our answer for this one. Hopefully you got that one correct. I'm going to see if this makes a mess again. I guess it goes up when I scroll up. Okay. Well, this one was based on a mystery science sequence that you should have looked at yesterday, all about volcanoes, right, and about where volcanoes typically happen. And this, for a lot of kids, would be kind of outrageous to think about a volcano being in their backyard. But I mean, Mount Baker is not too far from Mount Vernon, and we actually live in a very volcanically active place. So we're somewhat unique in reading this and answering these questions, and we'll keep that in mind. It says here that whenever you look at a world map, where are most of the volcanoes located? What pattern do they form? Let's see if I can drag this over a bit. Well, you see, and we've talked about this some in class, that there is this definite pattern that happens along South America, North America, Asia, and Australasia here. And even though it's called the Ring of Fire, it's not actually a full ring because there's nothing down here, right? Well, there is stuff, but it's not as actively volcanic. So in this case, most of the volcanoes form a horseshoe shape around the Pacific Ocean called the Ring of Fire. Okay. So moving on, why might you find lava rocks so far away from the Ring of Fire? Well, just because there's not a volcano there now doesn't mean that there wasn't one there millions and millions of years ago that left its basalt rock. So the basalt rocks, these lava rocks that are found away from the Ring of Fire, could have come from an active volcano that's either not near the Ring of Fire, because there are anomalies, or from an inactive volcano that doesn't erupt anymore, like the one that we saw in the video where it looks just like a rounded hill, but at one time it was definitely a volcano. And finally, is it possible for a volcano to erupt where you live? Many kids would be like, of course not. We don't live anywhere close to the Ring of Fire. Well, guess what? In Mount Vernon, we live in the Ring of Fire. Are in that proximity of the Ring of Fire. We have Mount Rainier, we have Mount Baker, we have Glacier Peak, we have Mount St. Helens, Mount Adams, and then on down through Oregon and California. We live in a very active volcanic area. So it is possible for a volcano to erupt anywhere, most likely, as it says here, near the Ring of Fire. And since we live near the Ring of Fire, it is more likely to happen. And believe it or not, Mount Baker is still an active volcano, even though it does not erupt. So, I hope everyone's well. I am posting the assignment for today, which is the 26th, in Google Classroom, so keep an eye on that. And I look forward to talking with you guys again tomorrow. Bye-bye.